Hello everyone, welcome to Dakshana E classroom program. I hope everyone did well in FST 22 and let's discuss about its solution for paper 1 part physics. So we are going with question number 1. So two pulses here traveling on same string as described by the equation. So equation of pulse 1 is 5 divided by 3x plus 14 whole square plus 2. This is pulse 1 and pulse 2 is given by minus 5 divided by 3x plus 40 minus, which actually here minus, and 3x plus 40 minus 6 whole square plus 2, right? Okay, now here mark out correct statements. So some options are given and we need to check whether it's correct or wrong about these two pulses which are traveling on same strings. At t is equal to 4 by 3, the two pulses cancel each other. So t is equal to 4 by 3. The point is how to check whether two pulses are cancelling each other is simply substitute this value and check whether y1 plus y2 is equal to 0. If it is 0, yes, in that situation pulses will cancel out. If it is non-zero means they will not cancel out. So in this situation, if we substitute t equal to this, then y1 we are getting is 5 divided by 3x minus 16 by 3 whole square plus 2. This is pulse 1, and pulse 2 will be minus 5 divided by 3x, and it will be like finally solving 16 minus 6 18, and this is plus minus 2 by 3 whole square plus 2. Now you can see these two are not exactly same, so if I am adding these two they will not cancel out. So this is not right statement. Similarly I can check for B statement. At t is equal to 3 by 4, t equal to 3 by 4. If I substitute this here, then you will get y1 is equal to 5 divided by 3x minus 3 whole square plus 2, and y2 also you will get minus 5 divided by 3x minus 3 whole square plus 2. Simplifying it, substituting, you will get this. You can check now for all value of x, if you are simply adding these two, they will cancel each other. So this is right. It's saying at t is equal to 3 by 4, second 2 will cancel each other everywhere. That's correct actually. Similarly for option C, so x equal to 1, you can check and you will get actually y1 plus y2 is coming out to be 0. So means that's also correct. 2 will cancel each other at all times. That is also right. Similarly at point D, like option D, at all point 2 will cancel out. Definitely at this moment it's not cancelling out for any point, is it? So they will not cancel out. So D is also not right. This B and C is the right option. And next question number 2. It's saying photoelectric effect is observed from metal surface from light of frequency 2 into 10 to the power 14 Hertz and 3 into 10 to the power 14 Hertz is incident. If maximum kinetic energy of photoelectrons in the ratio of 2:1, then which of the following frequencies photoelectrons are emitted from the same metal plate? So the question is, I think, easy and straightforward. Here two frequencies are mentioned, 3 multiplied by 10 to the power 14 Hertz and nu2 is equal to 2 multiplied by 10 to the power 14 Hertz. So for these two frequencies photoelectric effect is observed, and the kinetic energy K1 and K2, it's mentioned K1 by K2 is equal to 2 by 1. So by using these relations I can get the phi or function of the metal. So this is equal to h nu1, that is equal to 3 into 10 to the power 14 minus phi, some kinetic energy K1, and h multiplied by nu2, 2 into 10 to the power 14 minus 5 is equal to K2, right? Just simply dividing this is coming out 2 by 1. Simplifying it, we get actually phi is equal to h multiplied by 10 to the power 14, that is equal to h into mu threshold. This implies mu threshold comes out to be 10 to the power 14 Hertz. So this is the threshold frequency. Now what will happen? For which frequency photoelectric effect will be observed? For all the frequencies which are greater than this, photoelectric effect will be observed, and frequencies which are less than this, definitely we will not observe photoelectric effect. That you must be understanding already. So now you can check the options. So definitely A option, it's not right because its frequency is less than this threshold frequency. It's not. At B, 3 by 2, that means 1.5 times of this. So yeah, simple. And C, it's 4 by 3 means 1.33 times of this. So that's also correct. And T1 4 by 5, that means 0.8 times, or that's less than this frequency, so definitely we will not observe photoelectric effect at point D, at frequency D also. So again B and C is the right option for question number 2. Let's talk about next question number 3. So to partition, divide a container having insulated walls into two compartments, 1 and 2, as shown in the figure, and the same gas is filled in the two compartments whose initial parameters are given. The partition is conducting wall and it is free to move. You should remember, you should keep in mind every point that is being talked about. So here we have container and it has two partitions. So let's say this is partition 1 and 2, and pressure, volume, temperature, pressure, volume and temperature. This is conducting wall and free to slide. And remaining, this is insulating. So means no energy can go out of this system, complete system. This is the situation given. The partition is conducting wall which can move freely without friction. Which of the following statement is correct with reference to the final equilibrium situation, equilibrium position? So first thing is, what will happen actually in the final equilibrium situation when this system is released from here? Definitely you can see temperature is same on both sides, and here pressure is higher, so it will try to push this wall. So it will finally, let's say, moving here from here. This is the final position. So here volume will become, let's say, V minus V, and pressure will, because it's being compressed, so pressure will increase. And you can see this wall is free to slide, so it will keep on sliding until the pressure on both sides is not becoming constant. So definitely I can write in equilibrium, pressure on this side will be also constant. So I'm taking, let's say, it has increased by A amount, and because on both sides pressure will be same, so that's why I'm writing it P plus A this side also. And volume here it will be 2V plus some V, because V amount this volume reduces, so this volume will increase. And temperature T times T. Now see another thing. On this side, like earlier, both side temperature is same. This is conducting wall. So first thing is, at every point temperature on both sides will remain same. And because no energy is getting lost to the outside system, so that's why I can write final energy of the complete system will also remain same. That means temperature of both the compartment, even in the final equilibrium position, will remain same. So this is the situation. Now what we can write here is that for compartment 1 initial and final. So this is compartment 2, compartment 2. So I can write number of moles in each compartment must remain same, right? And we can use this relation. So this is like PV by T must be equal to P plus A V minus V divided by 2. I get equation 1 for compartment. This is for compartment 1. Similarly, for compartment 2, I will get the equation by conserving the number of moles of the gas in initial and final situation, and then I will get for compartment 2, it's 4PV by T is equal to T plus A 2V plus B divided by 2. This is equation number 2. And what are unknown here? A and B. Solving these two equations, equation 1 and 2, we get the value of A, it comes out to be 2P by 3, and B comes out to be, this is a 2V by 5. So this is the, now by like V minus B, I will get the volume of compartment 1 in final situation. So I can write V1 means volume of compartment 1, that comes out to be 3V by 5. V2 comes out to be 2V plus this, that comes out to be 12V by 5. Final pressure we already got that P plus A, so P final will be equal to 5P by 3. Now we can check the options. Pressure in two compartments are equal, that's correct. Volume of compartment 1 is 3V by 5, we are getting exactly same. Volume of compartment 2, 12V by 5, that is also right. And final pressure in the compartment 5P by 3. So this is all about problem number 3. So let's see next problem 4. Okay, so next question number 4. Consider a non-conducting ring of radius A in XY plane. The two semicircular portions have linear charge densities plus lambda minus lambda as shown. Then it's talking about finding dipole moment of the ring and electric field at the center of the ring. So this system, it's easier to directly deal in terms by simply considering the center of charge. Another way was to go with the integration part by considering small element here, another element there, and then you will get one small dipole and then integrate it basically. So I'm not going with that integration method. So we can write this system is equivalent to basically like here, this half of the ring will have total charge that is concentrated at its center of mass, and center of mass will be this distance will be 2a upon pi, and the charge will be lambda multiplied by its length. Length is pi a minus, and here it will be like minus plus pi a lambda, and this distance will be also 2a upon pi. So now I can write the dipole moment that is given by P naught, let's say magnitude. It's coming out to be charge multiplied with the total separations pi a lambda multiplied by 2a upon pi into 2. So this comes out to be total 4a lambda, a square into lambda is the dipole moment. Now it's because negative positives to direction will be this way, and this will be also 30 degrees. So we will have net dipole, I can write as P naught cos 30 degree minus I cap, and P naught sin 30 degree j cap, and just substituting and simplifying, we are getting it's 2 root 3, this is I cap minus and plus 1, this you can write j cap, and this is I can write lambda, this will be 2, yes, so it will be 2 will be also there, 2j cap, and this pi lambda a square can be taken out common actually, and it will be directed in minus direction, so it matches with option A. So this is the dipole moment of the system, and for calculating the electric field, we can simply break down this into two parts, so one semicircular ring, another semicircular ring. We know the formula of electric field due to semicircular, that is 2k lambda by r. So r is a here, and electric field due to this negative will be in this direction, positive in this direction. So that electric field, this should have positive component in x and y direction. Angle will be still same. So net electric field E net can be written as 4k lambda by a, that is equal to lambda by pi epsilon naught into a, and then resolving the component, then I will get E is equal to lambda by pi epsilon naught a. This is cos 30 degree I cap sin 30 degree j cap, and taking it lambda by 2 pi epsilon naught a, this is root 3 I cap and j cap. So this will be the magnitude of like net electric field due to this ring at the center, which matches with the option. So root 3 I cap, that is exactly with C. So the answer here is A and C. That's the correct option. This is our problem number 4. Okay, next question number 5 is a linear rigid rod of mass m and length L falls freely under gravity. So this is given about a rod of linear length L, mass m, falls freely under gravity, and finally it's striking a smooth surface. So this is the situation. At an angular position alpha with the vertical wall, so this is alpha. The rod making inelastic impact with the smooth ground at and A, and just after the impact it is talking about. So this ignite, it will have center of mass, will have some acceleration A, and after the impact it will be also like rotating with some, let's say, angular acceleration alpha. Angular acceleration of center of mass. A is the acceleration of center of mass, right? And here, once it is striking, normal direction will be there, mg. So now I can write mg minus normal direction equal to mass, equation 1. Now, only this will be applying the torque, so I can write m multiplied by L by 2 length, L by 2 into sine alpha, right? This distance perpendicular, so equal to m L square I by 12 into angular axis r, because alpha we are using here. So let me take it beta, then I will be writing it this I into beta. Now is equal to, this is equation number 2. Next thing is here, see, acceleration of this in vertical direction must be 0 to have net acceleration. So one will be like A, downward acceleration, and another because of rotation. So this will be like R alpha, and that will be like L by 2 into angular acceleration is beta. This acceleration, this is alpha, this is 90 minus alpha, this will be also alpha. So I can write the vertical component of acceleration of point A. Vertical component of acceleration of point A must be 0, and that implies, because it must have net positive acceleration, so this will be equal to this, A equal to this L by 2 beta multiplied by sine of alpha. So this is equation number 3. And the thing is, we can simplify. We have here like and A and beta, 3 unknowns. We can simplify this, and after solving it, we will get actually A is coming out to be 3g sine square alpha divided by 1 plus this is a 3 sine square alpha and g cap. Then it will be minus j cap, basically minus j cap. So this is the acceleration which actually like exactly matches with option A. So this is the value of acceleration A, and that matches with option. So this is correct statement. And solving it, we get the value of beta also actually, and beta comes. This is a relation between A and beta. We are getting this. So beta will be like divided by 1 sine alpha. So this will be like and 2. So this is 6g sine alpha divided by L 1 plus 3 sine square beta, and this is your angular acceleration. That will be actually, you can write minus k cap if you want the direction. Next thing is, now it's not talking about beta actually. So acceleration of center of mass will be like, that is A option, acceleration of center of mass. That's not correct. Acceleration of and A. So acceleration of and A will be equal to what? Acceleration of and A. So we have seen actually that in vertical direction net acceleration will be 0, but there will be component along this, and that will be equal to, so acceleration of A along x direction, that will be like L by 2 into beta into cos of alpha. And I can substitute this here, then I will get acceleration AX of and A will be equal to L gets cancelled, 2, 3 will be gone. So this is G, 3G sine alpha cos alpha divided by 1 plus 3 sine square beta, and it will be like minus I cap. So then we can see it's matching with 3g sine alpha cos alpha divided by 1 plus, that is matching with option C. So A and C are correct option for problem number 5. Right, this is okay. Next question number 6. Uniform triangular plate of constant area A and base length A is a capital A area, and the base length small a is placed on the smooth horizontal ground as shown in the figure. For the given condition, find the value of the theta for which the plate can remain in rotational equilibrium. So you might be getting confused with this diagram that is given in the problem. Actually the question should be like more clear with if I am taking something like this. So its area is A, then I can write base, this is B, and if I take, let's say, total height is H, then I can write 1 by 2 base multiplied by height should be equal to capital A. So I'm getting height is equal to 2 capital A divided by small a. Right, now let's say the coordinate of this is 0 comma 0, then it will be like basically A comma 0, and here it will be like x comma h comma 0, right? So these are coordinate. Then I can write for like this triangle should not topple, the center of mass must be lying behind this, because if center of mass is lying there, it will apply some torque and that can topple this triangle. So I can write for not toppling, is it, or I will write rotational equilibrium, same means rotational equilibrium of triangle. I can write the x, is it, center of mass must be less than equal to what, A. And x center of mass can be written as basically 0 plus a plus x divided by 2 must be less than or equal to a divided by 3. So this implies basically x must be less than or equal to what? X is, remember, this is the coordinate of this point, actually less than or equal to 2a. And then I can write tan theta is equal to what? This is the angle theta. Tan theta will be equal to what? It is like height h divided by its this distance, that is equal to x. So if x is less than this, then I can write tan theta will be greater than this. So I can, this implies tan theta will be greater than h. H is coming out to be 2 capital A by small a, and x is less than 2a, so 2a, then this will be greater than this. This implies theta must be greater than or equal to tan inverse a by small a square. Right, capital A by small a square. Now we can check the options. So greater than equal, so that means A is correct, B is correct, and C is less than this. So A and B both are right option for question number 6. Next, question number 7. So a vessel is partly filled with liquid. When the vessel is cooled to a lower temperature, the space in the vessel unoccupied by the liquid remains constant. Then volume of the liquid V1, VL, volume of vessel VB, and coefficient of cubical expansion of material of vessel and liquid are related. So this is like, let's consider this is a compartment like container, and its volume is V, and liquid is filled up to here. So this is the volume of liquid, and volumetric expansion coefficient is gamma L, and for this container it's gamma V. Then this unoccupied volume must remain constant whenever it is like cooling is there. So when the vessel is cooled to lower temperatures. So first thing is I can write volume of vessel at any temperature can be written as VV 1 minus some gamma V into, let's say, delta T. Similarly, I can write V liquid is V liquid prime 1 minus gamma liquid into delta T. And what is the initial volume? Volume of unoccupied space in this container, that can be written as V volume of container minus volume of liquid. So final also this, so V prime minus VL prime, that will be like VV minus VL and minus VV gamma V into delta T, and plus VL gamma L delta T. Now this quantity must be equal to what? VV minus VL, because only in that case this final volume, unoccupied volume, must be equal to initial. So this cancelled out, means this quantity should be equal to 0. Delta T simply cancelled out, so then we are getting actually VV into gamma V should be equal to VL into gamma L. This relation we are getting, and if we are rearranging it, gamma V by gamma L, then it will be equal to VV VL by V. So D option will be matching. And another thing is, here you can check, from here I can write gamma V by gamma L is equal to VL by VV. So see, the thing is, this quantity is less than this, so this overall quantity is less than 1, then gamma V is less than gamma L. Clear? So then we are getting gamma V less than gamma L. So A option also matches correctly, and remaining are not. So A and D is the right option for question number 7. Okay, next question number 8. A particle A, so it's mentioned particle A and B two are moving this way. A particle and B particle is moving vertically upward, moving with constant velocities along x and y, positive x and positive y direction respectively, shown in the figure. The graph of the separation and relative velocity between them with time is represented. So let's say its velocity is VA and its VB. I can write its J cap, its I cap, then relative velocity V relative, either I can write VAB or VBA. So this will be equal to what? A minus B, VA I cap minus VB J cap, magnitude VAB will be equal to what? Under root VA square minus plus VB square. You can see first thing is this, because VA and VB are individually given as constant, so that means the relative velocity will be remaining constant. So the graph of V relative versus time will be simply a straight line. That option matches with correct A. So definitely B will not be right. Then next it comes out to separation. So separation, if I'm taking it's, let's say, A at time t, it will be like minus VA into t. Similarly this time is B, then at time t it will be B minus VB into t. And now if I am writing the separation as function of time, it will be actually A minus VA into t whole square plus B minus VB into t whole square. And so this will not be a straight line because we are not getting linear relation. And definitely initially the separation is higher, they are coming closer, then they will be like start moving far like away. So separation will initially decrease then increase, and because it's not simple linear relation, so it will not be, the curve will not be a straight line. So here only like C and D two options are given. Most appropriate option, like which is matching from here, will be something like this. So this is separation versus time, so you can write D and A will be the correct options for question number 8. Next, question number 9. Here it's given two large metal sheets are given, two large metal sheets. Current here it's coming out of the plane. This is sheet 1, and another sheet is given here where current is entering into the plane. This, let's say sheet 2, and here we have marked, this is Y and this is X. This is the region A, B and C. So first thing is direction of infinite sheet is there. In case of infinite sheet, magnetic field due to a infinite sheet does not depends on the distance. So due to this, it will be like current coming outwards, so the magnetic field direction will be pointed this way. Around in this region it pointed this way, and due to this sheet in C region, again magnetic field will be in right direction. Now let's talk about due to this. So it is inwards, so we can get magnetic field due to this. Let me write due to lower sheet in the lower position, and here going inward, so it will be like again this way, going inward, so it will be this way. Now you can see, because identical sheets, infinite large sheets, definitely these will cancel out, so we can get B is equal to 0. Here also cancelling out, we can get B is equal to 0, but here B is non-zero, right? This is the information we can get by just interpreting the question actually. So two large metal sheet carry surface current as shown in the figure. The current per unit width is lambda, and here also a positive point charge Q is projected with the speed V at an angle 60 degree with x-axis in the xy plane in all three regions A, B, C as shown in the figure. So if a positive charge Q, mass M, and projected with velocity V with some angle 60 degree with the x-axis. So this way in region A, B and C. So if there is no magnetic field, what will happen? It will simply move in a straight line, right? So it will move undeflected in region B, because there is magnetic field, there is no possibility of moving undeflected. So that's not right statement. It will move, undeflected in region A and C. Yes, B is 0, B and 0. So B statement, in region A and C it will move undeflected. That's correct statement. It move in helical path in B. Now you can see in B magnetic field is in this direction and it's projected with 60 degree angle. So one component will be perpendicular, another component will be, let's say, V1, V2. Due to this component it will be describing circle, and due to this it will be moving forward, so the path will be definitely helical. We have seen such cases actually, so you can answer it straightforward. So then C seems right. It will move in helical path in A and C, so that's definitely, so B and C will be correct statement for question number 9. Okay, next question number 10. So the circuit diagram here is given to us. Let me first draw the circuit diagram. And this bulb B1, inductor, these bulbs like this. This is the system. B2 bulb and B3 bulb, and inductor L1, L2 and battery and switch. So the circuit shown in the figure consisting of 3 identical lamps and 2 coils connected to a direct current source. The ohmic resistance of inductance coil is negligible. The switch is closed for long time and then open. So first thing is switch is closed for long time. Now you must be like understanding, let's say if 3 identical bulbs resistance R, so what happen actually in infinite time or after long time, inductor behaves just like wire. So that means this source is DC, so there will be no impact of these inductors. Current I and I will be flowing in this way. So this is the situation before switch is opened, is it? Which of the following statement are correct for the instant immediately after opening the switch? So let's open the switch. Now what will happen? There is no supply. Initially current coming here is 3I. I is going this way, 2I this way, and like I going here, I going. So this was the initial situation before switch is open. After switch is open, here supply is broken, right? But the important point here is that across the inductor, current does not change immediately. So that means this inductor will still want the current to be flowing through this 2I even when battery is like disconnected. This will want still the current to be I, so that means current will be still flowing in this direction. I current will be like, because I cross this 2I, so that means I passing here, I passing here. Now these two currents, they cannot pass in this direction because circuit is incomplete here. So these two current will be passing here, so this in this direction. Now 2I current will be flowing. So this is the situation given. So you must be now clear that if higher current is flowing through any bulb, that means it must be glowing even brighter. So now we can answer easily, straightforward. All the lamps are turned off? Definitely not, because current will be there in each lamp and they will be continuously glowing. So brightness of B2 and B3 remain changed because current remain unchanged. In these two is not changing, so B statement is correct. Brightness of bulb B2 and B3 will not change. Brightness of B1 suddenly decreases. No, here current has increased, so it will not decrease. Brightness of B1 suddenly increases. That's correct statement. So B and T are right statement. That's about problem number 10. Let's see the next section, that is integer, single digit, integer type questions. Okay, next section 2, integer type problem, question number 1. So let me read first. Two identical triangular sets are used to measure the length of the rod. The division on the triangle are equally spaced. Means this division, if it is x, then this is also actually x, that is equally spaced. Division on, if the length of the rod is found to be, so length of the rod is 6.5 mm, it is measured. Calculate the division value of length in mm. So means we need to find the value of x in mm. Okay, so first you need to understand actually this problem. This problem is matching something like to vernier caliper actually. It's related to that. So here what is that? This is main scale and this will be acting like vernier scale. Now in this case, so division on main scale is actually equal to this. So main scale I will write MSD is equal to x by cos 37 degree. But this division is equal to this division, so that's why I can write vernier scale division. MSD VSD equivalent I am writing basically, that is equal to x. Now here two divisions, 1 and 2 division are complete, and plus third division is actually third division of vernier scale is matching with some division on main scale division. So then I can write the reading means length can be written as simply x by cos 37 degree multiplied by 2 because 2 division, plus least count will be MSD minus VSD, that is x divided by cos 37 degree minus x MSD minus VSD multiplied by the division which matches actually, and this length is given as 6.5 mm. Simplifying, because we know everything, like just solving for x, we get the x is equal to 2 mm, and that is the answer. So this is the value of division on like both triangles actually. Next question number 2. It's when a resistance R is connected in series with an element. So here resistance R and some element in box A, this is connected in series. The electric current is found to be lagging behind the voltage by an angle of 30 degree. Current lagging behind voltage by 30 degree means we can get some idea that it must be some equivalent like impedance, is it, for inductor or inductive reactance, basically I can write. So in this situation I can write then 30 degree is equal to what? XL divided by R. This is R and this implies XL is equal to R by root 3. And similarly in second case, uh, when the same resistance is connected in series with element B, current leads by 60 degree. So in second situation, same resistance connected to element B in and R. In this situation, it's mentioned current leads by 60 degrees. So that will be like XC divided by R, and this is 60 degree. Theta is 60 degree. This implies XC is equal to root 3R. In next case, when all three are connected in series, in that case what will happen? R, this is A and this is B. So in that case tan of phi is given by XL minus, or because XC is higher, XC minus XL divided by R, and this is root 3R minus R by root 3 divided by R, and this will be 2R by root 3R, and this implies RR gets cancelled, phi is equal to tan inverse 2 by root 3, and it's mentioned some k by root 3 something. So just comparing this, we are getting k value is coming out to be 2. So this is question number 2. Okay, next question number 3. So here is like 4 plates are given, P, Q, R, S, and some circuit connected. P, Q and R are connected to battery 15 volt, and P and S plates are connected. So now you can see actually here there will be P and Q plate will form one capacitor, Q and R will form another capacitor, and R and S will form another capacitor, and they are connected in some manner. So first we need to draw this diagram in some like simplified version. So first thing is, let me write, this is my point Q and here R, and some like I'm writing this is S, and P and R are connected here. So between Q and R we are having, so Q and R we are having one capacitors. This is Q and R, and between S and R I am also having like one capacitor, this, and between P and S there is nothing, P and S, and between Q and P also we have like okay, QP we already connected one, QP, yes, Q and R also we okay, and all right, just one thing, like I should be, because this I am connecting, this is R and this is P and S, because P and S both are at same potential, that's why I can connect both at same points. Now I should be like, so between Q and R, yes, so Q and R there is one more capacitor that I connected here like this, and Q and P, so Q and P we got this, and Q and S there is nothing, so Q and P we got one, and another one is R and S, so we had one more, and across this 15 volt battery is connected in this manner. Now it's talking about, after which the potential difference between plate Q and S. Potential difference between plate Q and S means it's talking about V across this VQS. This is asked to us. So first let me write here potential between PQ, like capacitance of PQ can be written as A epsilon naught divided by D. This is PQ. CQR is equal to also A epsilon naught by D, and CRS is given by A epsilon naught divided by 2D. So if I am taking this is C, then this is 2C, and this is also 2C. So QR it's 2C, and this is C. Between R and S it is C. So now see it, this means this 15 volt battery is connected one across this and across this, so we don't need actually anything across this. So now calculating here C equivalent across QR, C equivalent only for this arm QR, we are getting actually it's 2C divided by 3, right, in series combination. Then I can get potential difference across Q and R will be same 15 volt, So the charge on this and this capacitor Q can be written as C into V, that is equal to 2C divided by 5 multiplied by 15, that is coming out to be 10C coulomb. Is it? Now potential drop across this capacitor will be our answer. So V QS is equal to V across 2C, and that is equal to Q equal to what? C into V. So this is 2C into VQS, and 10C is equal to 2C into VQS. Solving, we are getting simply VQS is equal to 5 volt. This is answer. So let me explain it again. First thing is, here the diagram given is in terms of plate, so we will rearrange it. We will get this diagram in simplified form, and then there we just need to find the potential drop across this, and that is simple, straightforward. You can answer it easily, right? So this is problem number 3. Next, problem 4. A rod of length L has variable mass density where lambda is given as lambda naught 1 plus x by capital L. Lambda is not is the mass density. There exists an axis parallel to AB about which the moment of inertia of the rod is minimum. If the distance of such axis from AB is in the form of 5L by N, then find the value of N. So first thing is, here one rod is given to us, mass density is varying like this. This is axis AB, and at some distance x, lambda function of x is mentioned this way. Here it's straightforward answer. Actually we need to calculate like where movement axis, there must be one axis which is parallel to AB across which moment of inertia is minimum, and we know that axis passing through center of mass has minimum moment of inertia. So means we need to find simply the position of center of mass. That will be our straightforward answer. So we know actually xcm is equal to what? Lambda into x dx divided by integral lambda dx this, and that we can simplify. So it's lambda naught into x into 1 plus x by L dx, limit 0 to L, and here lambda naught 1 plus x by L dx, again limit 0 to L, and here we can simplify it. We get actually here answer this. I'm writing it directly, solving easy integration. Lambda naught will cancel out, or this will be x square by 2 plus x cube by 3 divided by x plus x square by 2L, substituting limit 0 to L, 0 to L. So it will be 5L by 6, and solving we get basically 5L by 9. So the value of N is coming out to be 9. It's straightforward, simple problem. You can solve it easily. So the value comes out to be for N, it's 9. Next, question number 5. So here we are given the space has electromagnetic field which varies with the time, whose variation is given as, so where initially 0 to t less than pi m by q b naught, its b is directed in minus k cap, and similarly like pi m by q b naught so on, it's directed to now minus b naught j cap, and electric field so on. So here let me first draw. This is the situation. Let's say this is x-axis, this is y-axis, and this is z-axis. So what is given? A charged particle having mass m, charge q, is given velocity initially v naught I cap, and for t less than pi m by qb greater than 0, b is equal to minus b naught k cap. So means now, right now, when it is projected, the magnetic field is inward, right? Then what will be like v cross b, the force will be upward. So we can see when a particle is projected with velocity perpendicular to magnetic field, then the path of the particle is circle, and where time period is given by 2 pi m by qb, and here we can say it's exactly half of the time period. So means how much path it will describe? Exactly half of the circle. So I can write for like t less than pi m by qb not greater than 0, I can write it will reach from here to path of the particle will be something like this. It will reach, this is the coordinate of particle at t equal to pi m by q b naught. Clear? Now what is happening after this moment of time? The magnetic field now changes to minus b naught j cap. So in now when it is reaching here, magnetic velocity is in v naught minus I cap. Now magnetic field is directed downward, is it? So now what will be the situation? Velocity this way and directed downward, so the particle will describe now a circle in xy plane. Now it's describing in xy plane. Okay, after that it will describe in xz plane, and the path will be like this. Actually it's parallel, and again because you can see next it's minus b naught j cap for this time to 2 pi m by q b naught. So exactly this will be also here radius. If I write this is, let's say, r1, then r1 is given by m v naught by q b naught, and here fortunately the magnitude of magnetic field is constant, so here also your radius will be like r2, or I can write both radius will be same, r and r, it is equal to r. So first thing is, at this time particle reached here, at time 2 pi m by q b naught, particle will be here, and its velocity will be again v naught I cap. Correct? Here the coordinates, here we can understand the coordinate is what? 0 comma, this is 2r, so 2 m v naught by q b naught will be the coordinate of this point. For this point the coordinate will be, x coordinate will be 0, y coordinate 2 m v naught by q b naught, and there will be z coordinate also, so this is 2 m v naught by q b naught, z coordinate. So that will be the coordinate at this point. Now what it is asking, charge particle having mass m, positive charge is given, velocity again at origin at t is equal to 0, the coordinate of the point on xy plane when it again passes through xy plane for the first time. So see, after this moment what is happening now, magnetic field is switched off, but there exists for t greater than 2 pi m by q b naught. Now we have only electric field, that is equal to minus e naught k cap. So electric field is down directed in this direction, this is E, right? So what will happen, the particle will experience force in this direction, it has velocity in this direction. So now we can see constant velocity but force constant in this direction, so the path after this will be parabolic. So for this moment path will be parabolic. Now we need to find first at what time it will cross this xy plane again. So acceleration, I can write acceleration will be in z direction. Az will be, force is q e naught divided by mass and minus k cap. This will be the acceleration. What is vz initially? Now at this moment of time, that I can write equal to 0, and z displacement, that is equal to 2 m v naught by qb. So this I can write, this is equal to what? uz into t plus half az into t square, right? So here I am directly writing, because otherwise I will be displacement, if I am writing then minus will come here also, initial position to final position. So it will be simply 0, and this comes out to be q e naught by m multiplied by t square into 2 equal to this. So finally we are getting t is equal to under root 4 m square v naught by q square b naught into e naught. So this is the time particle will take to like cross this xy plane again. I hope you understand this, because after this movement particle will be going in projectile path. It will be going this way and here it will be crossing, and this is the movement of time. And by this time, because velocity in x direction is remaining constant, so the displacement in x direction I can calculate the displacement in x direction. Is it from t is equal to 2 pi m by q b naught to t equal to 2 pi m q b naught plus, let me write it some t naught. This I can write x is equal to v naught into t naught, and this comes out to be v naught. I can just 2 I can take out, m I can take out, q naught I can take out. So this will be 2 m v naught by q under root v naught by b naught into e naught. So this will be the x component, and see here z will be what? This, but when it is reaching here z component will become 0 and y component will still remain same. So the coordinate when it is crossing this xy plane again, coordinate when particle crosses xy plane first time, is it? Then I can write its coordinate is, x coordinate is 2 m v naught under root v naught by b naught into e naught by q. Y coordinate, it is becoming 2 m v naught by y coordinate 2 m v naught by q v naught, and z coordinate 0. So now we are given in some expression. Now comparing this expression with the given in the problem, we can get the value of x is coming out to be 2 and y is also coming out to be 2. Now it's asking the value of x plus y, that will be 2 plus 2, that is 4. This is the answer for question number 5. So I hope you are clear. It seems like a little bit lengthy, I agree with that, but it's not complex problem. We just need to deal the situation of like this movement time interval separately. So initially for the interval 0 to pi m by q b naught, it's simple circular motion where it is describing half of the circle. From this to this means time this to time this, again it will be a circular motion with and describing half of the circle, but the plane will be in this situation, it will be like xz plane, and after that it will be a parabolic path again in same xz plane, and it will be crossing here. So we are dealing with like each interval of time separately, and then it seems easy. So finally we get this is the result. Let's see next problem number 6. Question number 6. The radius and surface tension of spherical soap bubble be r and t. So radius here it's initially r, surface tension t. Find the charge required which is to be given to the bubble so that its radius become 2r. So the charge is given to it, let's say q, then because of electrostatic pressure, is it? Or we can write on this wall, radius is becoming finally 2r, surface tension does not change t, and charge given to it q, and charge density is let's say sigma. In equilibrium, here atmosphere pressure is P naught, temperature of the air bubble inside remains constant. So temperature it's T, temperature T remaining constant initially and finally. And uniformly, charge is assumed to be uniformly distributed on the surface. Fill the value of Q by 96 pi into 10 to the power minus 10. So here first thing is, we can say the expansion of gas inside the bubble is taking place isothermally because temperature is supposed to be kept constant. Then we can write initially what is the pressure inside. So I can write initial pressure, volume, and P2 and V2. Temperature is T. Remember this temperature I am writing T for temperature. This is for surface tension, or I can write here let's say theta. Okay, so now first thing is What is P1? P1 can be written as P naught plus excess pressure, that is 4T by R. And what will be the pressure here? So P2 can be written as basically P naught plus excess pressure 4T by 2R minus sigma square by 2 epsilon naught. And final volume, because radius is becoming 2R, so I can write volume is V, then here volume will be 8V. Now by isothermal expansion from here to there, I can write P1 V1 must be equal to P2 V2. We can substitute the value, and this is P naught plus 4T by R into volume V. This is P naught plus 4T by 2R minus sigma square by 2 epsilon naught multiplied by 8V. This can be simplified actually. So just multiplying it, we are getting this is P naught plus 4T by R equal to P naught, 8P naught, multiplying it, and plus this will be like 4, 16T by R, because multiplying by force, and 2 it will be 416, minus this will be like 4 sigma square by epsilon naught. We need actually sigma because rest remaining things are given. So let me bring it 4 sigma square by epsilon naught, bringing this side 7P naught plus 16T minus, so it will be like basically 12T by R. Now we have everything given here actually. So this is 4 sigma square by 9 into 10 to the power minus 12, 7P naught, 7 into 10 to the power means 100, 12 into 0.07 divided by how much? Radius is 1 centimeter, so it's 0.01. So this cancel 84, 700 to 784, and this implies 4 sigma square is 784 multiplied by 9 into 10 to the power minus 12. 4 I can then is 196 into 9 into 10 to the power minus 12 sigma square. Now I can take basically square root, so sigma is coming out to be square root of this 14 multiplied by 3 into 10 to the power minus 6. So we get the value of sigma, charge density. Then what is sigma is equal to what? Q divided by area, surface area. Surface area is 4 pi into radius is 2R. 2R means 2 centimeter. So 4 pi R square. So this is 4 into 10 to the power minus 4. Right, 4 pi R square, its mass and radius is 1 centimeter. Yes, so 4 pi into 4 into 10 to the power minus 4. This is sigma, and that is given as 14 multiplied by 3 multiplied by 10 to the power minus 6. Okay, so now I need to rearrange it in terms of we need to find the value of Q by 96 pi. So first thing is, let me divide it this side, then it's Q by 4, like I can write 16 pi into, if I divided this side, then it will be 10 to the power minus 10, and this is 14 into 3. Clear? And this can be, we need to make it 96, so I need to divide it by 6, so that it will be like Q divided by 96 pi into 10 to the power minus 10. Then here it will be like simply remaining 7. So the value of this is coming out to be 7, and this is your answer. And this is problem number 6. Okay, question number 7. A wire AB of length 1 meter, area of cross section pi meter square is used in potentiometer experiment to calculate the EMF and internal resistance R of this battery. EMF E and internal resistance R. The EMF and internal resistance of driving batteries are, this is 15 volt and 3 ohm respectively. The resistivity of wire AB varies, so here its rho is not constant, it's rho naught into X, it's varying, where X is the distance measured from A, and so X is like distance of some point measured from A, and rho naught is given as 24 pi ohm. The distance of null point from A is obtained at, so distance, this is the distance of null point, distance of null point from A is obtained at this when switch S is open, for S open, and then we are asked to find the value of E. Okay, so it's let's see. First thing is let's calculate the resistance of wire AB. Resistance of AB, so that I can calculate rho into, because rho is not constant, so I will take small element dx divided by area, that is pi integral 0 to L is 1 meter. So this is rho naught into x dx divided by pi. Area is, this is actually A, that is pi meter square. So this multiplied by 0 to 1, and we are getting it actually here rho naught into x square divided by 2 pi 0 to 1, then it's rho naught by 2 pi. The value of rho naught is how much? 24 pi. So we are getting it's 12 ohm. So the resistance of this AB wire is 12 ohm. Then it's 3 ohms. So total current in this circuit will be equal to what? So I, if I write I, then I is coming out to be what? It's 15 divided by 3 plus 12, that is 1 ampere current. Clear? And now null point is measured at, found to be at x naught. So I can write for null point, is it the potential difference across this, because no current will be flowing in this, so potential difference of this battery, like basically EMF E, should be equal to I current in this multiplied by resistance up to here. So we got the expression of resistance in general term. Resistance for up to this length, I can write resistance of part of AB up to null point, that I can get easily. It's rho naught into x square divided by 2 pi, where 0 to root 2 by 3, and this we are getting 24 pi multiplied by 2 by 3 divided by 2 pi, we are getting it 8 ohm, right? So now EMF of cell is given by I multiplied by R of this part. Basically, let me write, this is R1, so this is R1, I is 1, it's a ohm, so this means 8 volt, and this is the EMF of the cell. So the answer coming for question number 7, it's simply 8 volt. Okay, next question number 8. So here, to determine the half-life of radioactive element, a student plot a graph of ln mod of dn by dt versus t, where dn by dt is the rate of radioactive decay at time t. If number of radioactive nuclei of this element decreases by a factor of p, and p factor in 4.16 year, then the value of p. So this is the problem. What we can do is, actually, if I'm taking this is y, first we can write the equation of this. So here, like according to the data given, next it's like here decreasing to 3, it's becoming 6, so the slope is coming out to be -1/2 here, and y will be like 6 minus x by 2 will be the equation. Y is actually this, so we are getting another is n equal to n naught e raised to power minus lambda t. Now if I am differentiating it, dn by dt equal to minus n naught lambda e raised to power minus lambda t, then mod of this is simply gone, is it, and taking log on both sides, so ln dn t by dt, rearranging it, we get it actually ln lambda n naught minus lambda into t. Now comparing here, and x is equal to what here? T. X is actually t. So now comparing this relation where y is, let me write it properly, ln mod of dn t by dt. So now this equation and this equation, then what it implies slope is equal to lambda equal to 1/2. Basically lambda equal to 1/2 and slope is coming out to be -half. So that implies lambda I got. So then n equal to n naught e raised to a minus t by 2, because lambda is 1/2. Now it is asking, in this interval of time, these become some like fraction, is it? So let me first calculate what is this fraction, n by n naught e raised to minus t is 4.16 divided by 2, is it? This we can calculate, actually solving it comes actually n by n naught. The value of this expression is 1/8. So now it's saying if the number of radioactive nuclei of this element decreases by a factor of P after 4.16 year. So what is that factor? We can say it's basically P is 8. So this is the answer for question number 8. Next, question number 9. Here two setups are given. This focal length 10 centimeter, 20 centimeter and screen. Another case 20 centimeter, 10 centimeter and this screen. Intensity I naught is incident and here also I naught. So what will happen, its focal length is 10 centimeter, it will converge completely here, and then what will happen, it will go actually in this way. Now because this is 10 centimeter, this is 20 centimeter, so I can write if whatever the radius it's coming for r, then definitely it will be like 2r. Energy is same, so here area is a, then here area will be 4a. So whatever the intensity here reaching, I can write power incident is I naught multiplied by a, and here intensity, let's say I multiplied by total area is 4a. So these two power must be equal, so I'm getting I1, let's say I1 equal to I naught by 4. So in this situation, first case intensity on the screen will be I naught by 4. In this situation it will be converged here, that is at 20 centimeter. So here if area is a, I am taking, then it will be like I naught into a is the power incident. Now after that we can see it will be like going up to here. So again I can write if this area is a, then here area will be like, because this radius is r, then this radius will be only r by 2. So area on which this light is falling will be simply a by 4, right? So this I can write I2 multiplied by a by 4. This implies I2 is coming out to be 4 I naught, right? Because here finally light is like converged or to like small area, so definitely because power incident is same, so area is reduced, intensity will increase. So then we are getting I2 is 4 I naught by 2. Now here it's talking about the if the ratio of I2 by I1 is of the form of n square. So let me calculate I2 by I1. It's 4 I naught divided by I naught by 4, that is 16, that is equal to 4 square. So then find the value of n, that comes out to be 4. So value of n is equal to 4. Next and last question number 10. The x coordinate of particle moving on x-axis is given by, so x is given as 3 sine of 100 t plus 8 cos square 50 t. This is the expression. It can be rearranged little bit. 3 sine of 100 t plus 8, I can write this is 4. So then it will be 2 cos square theta. That can be expressed as 1 plus cos 2 theta, and that will be like 100 t. So this implies it's 3 sine 100 t plus 4 cos 100 t, and this is basically 4 plus 4 cos 100 t plus 3 sine 100 t. A cos theta plus b sine theta, that can be written as under root a square plus b square something cos of omega t plus some phi. So actually this can be written as 4 plus under root this square plus this square, that will be 5 sine of omega t, plus it comes actually 53 degree after solving. So that means it's talking about the maximum value of it. So maximum value, this 4 will be there. What can be the maximum value of this? And that will be like simply 5. So the maximum value of x, maximum value of displacement x can be equal to 4 plus 5, that is 9, and this is your answer. So this is because all x is given in centimeters, so final it will be also 9 centimeter. This is your answer. So that was all about this FST 22 paper 1 part physics solution. I hope you understand. Thank you so much.